Hello, everybody. Can you hear me? So we are starting the fourth session of Network Operations, and today we have Ms. Shoko Miyagawa from Keio University with the topic ICT Utilization in Disaster Response from the case of Nepal 2015 earthquake. After her, we have Philip Pops. He's a troublemaker, but he's also from FreeBSD Foundation. And then we have Monsieur Alain Durand from ICANN with IPv6 adoption worldwide. So I would like to welcome Ms. Shoko Miyagawa with her presentation. You're welcome. Do you want to use the mic?
Good morning, namaste. My name is Shoko Miyagawa from Keio University, Japan, and I'm also a member of EpiNurses project in Nepal. And EpiNurses project is a trial of the development of disaster nurses in Nepal. And I guess many of you imagine about disaster medicine or disaster nursing is to go to the disaster happened place just after the disaster happened and rescue people who are buried in corrupt buildings. But actually, the real health risks is coming after this kind of acute period. So we are conducting a joint continuous monitoring to prevent the outbreak of communicable disease after the victims gathered to the shelters. And our activity of EpiNurses received the Risk Award at the 2017 Global Platform UN ISDL. And this is, this is Apsalamam, the leader of our EpiNurses project, and she is Taramam. She is the leader of Nursing Association of Nepal. So we are jointly proceed this EpiNurses Nepal project. And why I'm standing here today is I want to let you know the real health risk come to not always just after the disaster, but the 3 months, 6 months after the disaster. And EpiNurses do assistance, health assistance for in the shelters after 3 months, 6 months, and 1 year after the disaster. And also we are seeking networking with carriers and ISPs in Nepal because we are quite interested in introducing ICT to do rapid monitoring and rapid report. So we think that pairing with our project and the ISPs or networkers in Nepal is preparation for coming next disaster. And Nepal experienced a huge earthquake in 2015, and about 2/3 of the national population affected with this earthquake. And disaster, just after disaster, there is acute health risk. But after 2-3 weeks after the disaster, people starting to gather to the shelters, and communicable disease will occur in this stage. And also, there are some kind of sexual abuse, or chronic disease, or pregnancy, mental disease, or disuse syndrome, and so on. But these health risks are not always recognized by government. Because to grasp these health risks, we have to assess from various aspects, like tents, food, water, clothing, and toilet, or how many pregnant are there, or how many infants there, how many school children there, how many sick or injured people there. So we have to know a lot of things to assess the health risks. But to grasp these risks and to gather this kind of information is not very easy work in a disaster situation. We sometimes say no news is good news, but in the disaster situation, no news is not always a good news, because no news from the disaster affected have not as disaster nurses. So, and because there is no media to integrate that kind of information, we sometimes have to make decisions with very limited information. For example, Ministry of Health only monitors county hospital, and WHO set up the mobile clinic, and they only monitor these mobile clinics. But sometimes the victims are in shelter, and communicable disease happens in shelter, but they have no transportation method to go to county hospital or even mobile clinic. So, okay, thank you. So, only monitoring county hospital or mobile clinic, they cannot grasp the real information about victims. Victims are there in shelter, and community nurses are in shelter. So by training community nurses as a disaster nurses, we can grasp this real situation in shelter. In EpiNurse project, the primary driving organization is Nursing Association in Nepal, and they called the community nurses from each area, and we trained the community nurses about public health and health monitoring in shelter. And also we introduced IT tools like mobile smartphone or tablet. And these EpiNurses went to these areas, and there are 24 EpiNurses in 24 shelters in a disaster-affected area. Dangade or Padmata, Lapa Basti, and so on, so many places. And today I introduced the case of Melamchi, Sindhupalchok. Sindhupalchok is about 30 kilometers, 20 or 30 kilometers from here, Kathmandu, and it takes 3 hours drive. And we went to there last August, and it was rainy season, and drive was quite nice. We kept on shaked for 3 hours. Very nice drive. And this is the basic reference value before earthquake. And yes, people, some people can read and write, but some cannot read and write. And there are community nurses there. She's Roshani. Roshani ji acted as EpiNurses here in Melamchi. And she knows a lot about the city of Melamchi. So we interviewed her and gained information, the community information from her. And she visited continuously shelters and count the population and assess the hygiene environment of shelter. And after, this is the report from April 2016. So this is 1 year after the earthquake. And there are still no clear water, no water supply, and no clean food. There is a kitchen, but no waste storage. And toilet was okay. And they said electricity was yes, but it means that there is a solar lantern. So I decided to switch it no. And there's no spacing, no cleanliness, and no blanket. So, and this is the primary health center in Melamchi. And there's no, at the time of April 2016, there's no communicable disease happening. And this kind of surveillance of shelters are not performed by government or by hospital or by WHO mobile clinic. So they do not have such kind of information. So the lack of information is cause of the wrong decision. So the collecting the shelter information is very important. And ICT can contribute for collecting data and rapid reporting, which helps grasping situation timely and help their decision making. But first, we have to investigate how the EpiNurses can utilize ICT. So we held a 2 days workshop in 2015, September 2015, before EpiNurse goes to the shelters. And we had a 2 days workshop and had various kind of training here. And we understand that, we noticed that they cannot figure out where their shelter is on the map. And their map drawing, it was quite poor, because they haven't trained to read and draw maps. So these are the findings from the workshop. There is a high expectation to introduction of ICT, and most of the nurses uses smartphone, mainly Android. And power and data communication was unstable, especially in a rural area and disaster-affected area. And slow network and high cost prevent them from continuous use of data communication. Actually, in the current situation, we actually had a EpiNurse workshop yesterday and the day before yesterday here in Kathmandu. But most of the EpiNurses still do not use the 4G network. They only use Wi-Fi because it costs very high. And about information literacy, the main use of the smartphone is mainly messaging. They do not use maps, or they do not use as a video conference application. And skills for utilizing the information on the internet, map literacy, data literacy have not been well developed. And the importance of health monitoring was also not being necessarily understood from the beginning. And the cooperation between primary health center and county hospital are not working well. And there is a large variation in ability of health assessment in individual nurses. Because of this, it is difficult to carry out a health survey of all of the items in the items to be surveyed in the shelter. So we developed a monitoring application under the collaboration with Kathmandu Living Lab, which is this is a civic tech company in Kathmandu, and they're performing OpenStreetMaps. And under the cooperation of KLL, we developed a shelter surveillance tool, which worked on Android. And we also set up the monitoring tool bag, and we developed the tool, and also we prepared the paper-based survey sheet, because not all the nurses are very familiar with using smartphone in that way. And actually, about 20 nurses of 24 nurses uses this paper-based survey sheet, actually, at the time of 2016. So, and then we assessed the communication, data communication environment. And we, last year, in 2017, when we came first here in Kathmandu, there's no 4G network, and Wi-Fi was very slow. But in current situation, as you know, there are 4G networks, and Wi-Fi becomes very fast. And it is at the survey at the time of last year, August. And here in Kathmandu, and we went to Bhaktapur and took a car, and there's a 0 kilo bus stop, and we went to Melamchi, and then walked 2 hours, and in top of the mountain, there is an elementary school. And the situation of 4G network was quite well in Kathmandu and Bhaktapur, and at the 0 kilo bus stop, only Ncell was available. We couldn't use NTC here. And in Melamchi, it was okay. And even in top of the mountain, the NTC and Ncell was available. Not very fast, but it was available. So we think the communication environment developing rapidly in the Kathmandu area, not only Kathmandu area, but also other areas in Nepal. So we can utilize this communication environment for shelter assessment, we guess. And we simultaneously trying to developing the information literacy and map literacy for EpiNurses. And we trained the map application and EpiNurse application for nurses. And please look this map. This is after our workshop, and this is before workshop. Their map literacy, map drawing skill, I really impressed that their map drawing skill improved greatly. And we also improved our monitoring application. The last one is just for monitoring shelters, but we developed the new application about the school nurses and community nurses and maternal and child health nurses. These apps are for daily use, for their daily use. And there's also apps for disaster nurses. So if disaster happens, they can switch the application to the disaster nursing application. So they can keep on using the same app in the disaster situation. And currently, we are working for organizing EpiNurse organization and collaborating with the government or county hospitals. And also, we are developing human resources, and we are developing good UI and tools. But we need data communication infrastructure. That's why I'm talking here now to you. And we are seeking the integration of this kind of data into SDGs, Sustainable Development Goals by United Nations. And also, we are seeking interoperability with the WHO emergency medical team and humanitarian data exchange, humanitarian data exchange performed by OCHA UN. Okay, that's all of my presentation. Thank you.
Thank you, Shoko, very much. Does anybody have any questions for Shoko? Okay. I have one question, sorry. Do you think you would be able, if something like this happens again, I don't want to jinx anything, do you think you will be much more ready than before? That the lessons are really learned?
Yes, to do rapid monitoring, we think we have to connect with the internet service providers in Nepal or data carriers in Nepal. So if we can connect, we can perform more rapidly and more good performance.
Okay, thank you very much. So operators, you heard. If you want to talk more with Shoko, I'll guess be around after this session. Okay.
Thank you.
Oh, another question, great.
Hello, my name is Taiji from JPNIC. This is a comment. We have the disaster response or recovery sessions in New Zealand in Apricot or EpiNIC meeting, I think. And this type of session is very important and also, so this is a kind of feedback for the chair or the program committee to continue or reconsider the continuing this type of sessions because other topics in the session have a different type of topics. So maybe we can gather the case studies as one session, then we can have the discussions between us, I think.
Oh, thank you very much for the suggestion. Thank you. Thank you, Shoko. This was very educational. Okay, so our next speaker is Philip Fobbs, and the topic is, this one goes to 11.
Excellent. Hello, everybody. I feel slightly out of place after the previous presentation, so I usually like to introduce this talk as the FreeBSD Foundation, which we try to make positive change in the world, but it's clearly a very different world than the one from the previous speaker. When I say things like making lives better, I mean the lives of systems administrators. I don't mean the lives of people as a whole, so just keep that in mind. How do I go to my next slide? There should be a widget. Is this the thing? And is there the big button? The biggest button. All right, great. I'm not a very smart monkey. So yeah, so this presentation was originally titled FreeBSD is not a Linux distribution and was geared to systems administrators or network or DevOps who live in a Linux world, and we wanted to remind them that they don't really have to live this way. There are other open source operating systems that have plenty of nice features and have been around for a long time. And especially in the networking community, FreeBSD has been very popular over a period of decades. And people come and go, but I'd like to go through the nice things we have in FreeBSD 11 or 11.1 now, especially for network people or people running network servers. So I'm actually not a networking person or a systems administrator or any of those things. I'm a kernel hacker, and I run conferences. And usually my comfort zone is several layers of abstraction beneath the network. But I'm a director of the FreeBSD Foundation, and I travel around the world to conferences, helping people with FreeBSD, and travel to several organizations and tell them, what can FreeBSD do for you? So I've had several conversations in the hallway track this week with people from several organizations. I think most people know what FreeBSD is. But just in case you don't, FreeBSD is a complete open source operating system. By complete, we mean that you can install the operating system and it is ready to go. You don't need to download several packages to get an editor. You don't need to figure out the exact collection of tools you need to get your work going. When you install it off the CD or USB stick or from the internet, you have a complete operating system ready to go. Just like you would have if you had a Mac, for instance, or a Windows machine, except on your server. The entire operating system is open source, and it implements the same POSIX and Unix interfaces that more recent open source operating systems like Linux have started implementing. So more than 24,000 open source packages just run on FreeBSD, just as they would run on other Unix-like operating systems. And the thing that sets FreeBSD apart from many other systems is that we come with complete documentation. Everything on the system is documented, and is documented on the system itself. You do not need to paste your stack trace into Google or another search engine to figure out what on earth your system is doing. And this is something I think is very important or very useful to systems administrators whose job it is to keep their systems going, and they don't want to engage in any kind of operating system developers. The system just has to work. FreeBSD is also a community, and I'll talk a little bit more about the kind of community we are and how it has some parallels with the networking community. So you might be surprised to see your company name on this list, because it turns out that you can use FreeBSD without telling anyone about it. So all of these companies use FreeBSD for something or other. They might use it as the base of their derived operating system. They might use it to run some part of their network infrastructure, or they've just taken bits and pieces from it to build other products. But all of these companies are large consumers of FreeBSD, where large is anywhere from their business depends on it to their business depends on some subset of FreeBSD. So why do people want to use FreeBSD? Well, innovation is a key thing. The history of the internet and the history of the BSD Unixes has been very closely intertwined for the past 30 years and more. FreeBSD has always been on the leading edge of developing certain technologies, both in networking and in storage and other things. Sometimes it feels that FreeBSD development is going a little bit slower, but that's because we're actually thinking about things. Eventually, things land in FreeBSD, and then they will be complete. So it's innovation, but it's conservative innovation. We think about things, and we get them right. FreeBSD has a great tool set. I'll go through several of the tools in a bit, but we have a whole collection of tools, and these are all installed with the base system when you start, when you've got it. We've also got a mature release model, by which I mean that if you deploy FreeBSD in your organization, you have a way to plan forwards. You know that every so often there will be a release, and you know what kind of changes to expect in this release, and you know that there will be no surprises. Our release model is not like certain Linux distributions where every year you need to reinstall everything and relearn and retrain all your engineers. We believe strongly in the principle of least astonishment, so we have gradual forward progress, and you can upgrade your system and not have to face several surprises along the way. If you install FreeBSD 11.1 today, you have a guarantee that the entire system will continue to work without any sort of surprising jumps and leaps forwards as you go through the 11.x series and then upgrade to 12. If you installed FreeBSD 6, say about 8 years ago, you will have been able to upgrade this system every step of the way without any material impact on your production systems, or without having to reinstall, or without having to retrain all your engineers. I've already mentioned our documentation. Our documentation has also been translated into several languages, and if you like translating documentation and you want to join a friendly open source community, you should talk to me, because we are missing several South Asian languages and we'd love to get them. Less important to this conference is that the BSD license is very business friendly. Several open source tools use the GNU license, which requires you to release all of your source code under the same license. The BSD license is not like that. The BSD license is basically share and enjoy. Here is some software, go off and use it. And I can't stress this enough, but the FreeBSD community is a very open and welcoming community, much like the internet community. And it's just a lot less adversarial than other open source communities, which I'm not going to talk too much about. But anyway, so we produce a complete operating system. We produce the operating system, we produce device drivers, compilers, associated tools, debugging tools. We have all the debugging tools maintained by the people who write the software. We have editors, a packaging system, and the entire operating system is ready for coding when the install is done. It is also ready for being a DNS server when it is done. It is ready for being an authentication server. It is ready for being whatever you need it to be as soon as you install it. You don't need to go and look around for, okay, what's the next step? The documentation is right there on your system, and the system is ready to go. So several people or several networky organizations used FreeBSD in the early 2000s, but then ran away because we spent a little bit too much time on getting FreeBSD 5 out the door with running on multiple processors. So I'd like to go through a little list of things that are new, or new if your last exposure to FreeBSD was FreeBSD 4, and which are, these things are not new, but these things are nice in FreeBSD. So we have a new package manager. If you use FreeBSD in the early 2000s, you'll remember that our package management was not very easy to use. It worked well, but it involved, sacrificing a chicken from time to time to make it do what you want. So about 5 years ago, we've replaced that completely with a new package system, which, and we made sure that it is possible to upgrade from the old sacrifice the chicken system to the new system without surprises. And we now have a really good package manager that allows you to trivially build your own packages using our Poudriere build tool. We've also added binary system updates so that you can install FreeBSD releases more easily across your collection of servers or whatever it is you build on FreeBSD. Instead of having to build it yourself, you can just type FreeBSD update install, and it will upgrade your system for you. And we are confident that the system is reliable enough that you can even run this as a scheduled cron job in the background and just upgrade your operating system on a single release branch without having to have someone sitting next to it and keeping an eye on it as it upgrades. We've added several new features in the last 10 years or so. Our SMP performance on multiple cores is excellent. We've got a memory allocator that works really well on workloads across several CPUs, and we've got the ZFS file system. As far as I know, ZFS is the only open source file system that does not eat your files. So every other file system I've encountered will eat your files. ZFS has been engineered not to eat your files. And along the way, we've also made several improvements to old favorites in FreeBSD like jails and our RC system, which starts up the system. So file systems in particular, I want to mention. I know this is a networking conference, and it might seem disingenuous to mention storage, but even networking people have data they care about. So FreeBSD has two file systems. We've got the traditional Unix file system, which is high performance and has grown snapshots in recent versions of FreeBSD. And we've also added journal self-updates. So UFS has always been known as being rock solid, and it will keep your data safe. But if you have a lot of data and the power goes out, you'll spend a week checking the file system consistency. That's no longer true. We've got soft updates and snapshots to recover your file system easily after the power goes out or something unexpected happens. And secondly, we've also got the ZFS, the zettabyte file system, which was originally written by Sun, which is both a file system and a volume manager. So it's really nice if you've got a lot of storage and a lot of things to store on it, and it can cope with different reliability requirements on your file system. So you can tune it to your workload. It runs very well on FreeBSD. It's fully up to date on FreeBSD. We track the upstream ZFS community really closely. And we even put things get started by FreeBSD developers and then come in via the, when they get in the upstream ZFS distribution. So we're very active in that community as well. I've mentioned jails. FreeBSD still has jails. For those not aware of this, jails are a lightweight virtualization. It allows you to lock up a process in a little container where it can't escape. It's like what Docker thinks it does, but it actually works. So it's a separate file system namespace, and we've added in FreeBSD ZFS delegation feature. So you can say in a jail, this set of my file system, this pool of storage belongs to this jail. Nobody else can touch it, and the people in this jail can't touch other things on other ZFS pool. We've also added vimage network stacks, a little bit more about that, which allows you to give each jail its own network stack without going through the trouble of virtualizing the entire kernel. You just say, okay, here's a jail. You've already got a separate file system. You've already got a separate process namespace. Here you go. Have your own firewall as well. Have your own routing table. Have your own what have you. Here you go. Have a network stack. So that you can do that in FreeBSD out of the box. So the use cases for these jails are, well, the most common use case is web-based virtual hosting, because websites keep getting more complicated. It used to be a website was a bunch of HTML files sitting in a directory and a web server pointed at them and everything is fine. These days, websites are databases and websites have sockets and things talking to them. So a web server needs a firewall underneath it, and a web server needs some kind of database and active storage mechanism to talk to things. Email hosting is very nice. You don't want your email to be shared among other people's email. So it's a security sort of feature. And so the general way of putting this in the new speak of the 2010s is that jails provide service isolation with microservices. So I don't use that sort of language myself usually. So let's talk a little bit about this network stack we've got. So TCP/IP was originally developed on BSD, and FreeBSD is just a direct descendant of the original BSDs. And we're still the reference implementation for many network protocols. So the one that usually comes to mind is SCTP. It was developed completely on FreeBSD, and FreeBSD continues to be the reference implementation for SCTP. FreeBSD has complete support for IPv4 and IPv6. You cannot find an RFC crazy enough, or someone will have implemented it on FreeBSD. My favorite example of this is the evil bit, which was in the 1st of April RFC a couple of years ago. It took about 10 minutes for that to be implemented in FreeBSD. It was quickly removed again because it's a silly idea, but it was in FreeBSD, and we support every IP option, we support every TCP option, no matter how crazy. We'll turn the crazier ones off by default, and the really crazy ones will back out again, but everything is supported on FreeBSD. We have active development going on TCP. I see Jeff's in the back of the room smiling, grinning at me, daring me to say terrible things. But we're active in the development of TCP, and we've added pluggable congestion control. So previously, if you wanted a different congestion control algorithm, you'd have to rebuild your kernel, and that would take you time. And you're network people, you don't want to compile kernels. So now that's become pluggable, and you can have your choice of poison on your TCP stack. So let's talk about these pluggable TCP stacks. BBR, it's in current. It will be in 11 soon, I promise. I'll chase it down myself. We've got Rack, we've got Cubic, and if you really want it, we've got New Reno as well. And the pluggable TCP stacks makes it really easy to do some congestion control research on FreeBSD. It used to be that you had to write a lot of kernel code to just change it's a fairly fundamental aspect of TCP, but it shouldn't be that hard. We've made it a lot easier now. Over the last, 30-year history of FreeBSD, we've made a lot of performance improvements to networking. So this slide actually comes from a computer science course which is taught on FreeBSD in Cambridge, which shows you how the FreeBSD project over years has made actually massive changes in architecture and microarchitecture over the years, while still providing a gradual path forward without surprises to our users. So we've gone from polled 10 megabit half duplex networks to currently having 100 gigabits line rates on FreeBSD just working without having massive instability or massive surprises along the way. So here's a couple of the improvements we've made in FreeBSD over the past, or BSD in general over the past, say, couple of decades, say 35 years or so. And the slide stops in 2012 because we've made improvements so often that it's not possible to put this table on a slide. And I don't like having tables across two slides, so the table stops. So we started by implementing BSD sockets in BSD. And then in 2012, we had pluggable congestion control, and the slide just goes on and on. We've not been sitting still. You don't hear from the FreeBSD community very often, but we are there and just gradually doing work. I'd like to highlight our transport community. So we are active, or some people are active in this community, developing and testing the new congestion control algorithms as they come out. So, and these people have a transport meeting every month, I think, to just talk to other people and other operating systems, the Packet.NET folks, or people running Linux, or people running proprietary workloads on FreeBSD. If you are at all involved in doing transport work, you should definitely consider joining the transport calls or joining the FreeBSD transport working group, because we're there to help you and you can help us as well. Right, so this is a networking conference. I must mention Firewalls, and also there's one of our firewall maintainers in the room, so I'm just going to troll him. FreeBSD has your choice of firewalls. We've got 3 different firewalls, and you can use them all, you can't use them all at the same time because that would be crazy. But if you're using vimage, you could say one jail is using one of them, the other jail is using the other, and so you can move your system forwards with causing the least amount of surprise to all of your users. So we've got IPFW, which is our native firewall, and it actually gives you the best performance. We've got PF, which is ported from OpenBSD and is the easiest to configure. And then we've got IP filter, which we still keep around because we believe in the principle of least surprise. If you've invested a lot of time and efforts in configuring IP filter several years ago, we don't feel it is appropriate for us to go and break that existing behavior. If it works for you today, we feel it should work for you tomorrow. If at some point it becomes unmaintainable, we will give you several years' notice before throwing anything away. Some other things we have added to FreeBSD which might not be familiar to everyone. Our jails used to be a cheroot with an IP address. That has not been the case for several years. You can now add multiple IP addresses to your jails. You can add multiple IPv4, multiple IPv6 addresses, and all of this just works together. I've mentioned vimage. I'm not going to mention it too much more. But also in networking, you can run all of the usual tools like Zebra, Quagga, Bird. All of these things just run on FreeBSD. You might think that, but they're Linux routing projects. They're not. They're open source routing products, and they will work out of the box on FreeBSD without any difficulty. I know ISPs, smallish ISPs, that run all of their routing on FreeBSD rather than spending a lot of money on bespoke routing platforms. I've mentioned vimage. I'm not going into it anymore. We do things like IPsec as well. Raccoon was developed on NetBSD, I think, but it's now also in FreeBSD. And we even have a layer 2 stack. I have to admit that our layer 2 networking support is not as great as it could be, but we do support all of the usual suspects like .1d bridges, .1q VLANs, and even .1q priority tagging now, link aggregation and spanning tree, that sort of thing. It all just works. And we have very nearly working MSTP support, so I need to just sit down and commit it one of these days. I've mentioned our transport community. our network stack is alive and kicking on all layers, from a piece of string connecting you to the internet to the sockets talking to your higher layer software. Virtualization comes up at these conferences very often because it becomes increasingly difficult to buy modest hardware. So we provide ready-to-use images for VMware, VirtualBox, QEMU, and Hyper-V for download. So you can go and download FreeBSD, and you can stick it on a VM, play with it, and then decide you don't like it and throw it away, or configure it until you're happy with it, take a snapshot, and put it in production. That just works. We also have our native hypervisor now. I think everyone gets stares themselves blind on this KVM thing that's in Linux. We have a hypervisor on FreeBSD as well. It's called Beehive. It was originally developed by NetApp, and it can run Linux, Windows, and FreeBSD images out of the box, just like that. It works just as well as KVM, except that its command line options are not unintelligible. And it's BSD licensed, so if you feel that you want to build a hypervisor on top of it, go right ahead. The source code is there. Go and use it. We've got some security things as well that started in FreeBSD and are now making their way into other operating systems. So we've got Mac and audit framework, so you can audit whatever is going on your system, and it will work. We've got Capsicum, which allows you to go even more lightweight on locking processes up. You can say, this file can be read but not written to, and you can enforce this with a capability. And you can say, you can only reduce in privilege, you cannot gain more privileges. This is a technology that's been in FreeBSD for several years. So things like TCP dump, you can run TCP dump in confidence that a bug in the dissector for whatever protocol is not going to eat some file somewhere else on the file system, because the codes that's dissecting whatever random protocol people are throwing at your wire is not going to be allowed to touch any of the other codes running, the printing to the console or the writing of the PCAP file. So it's strongly sandboxed within a single process. And then there's some good news for people who are running proprietary applications on Linux, and I'm thinking particularly any ccTLDs who are stuck or who are using bespoke, let's say, TLD management software. FreeBSD has something called the Linux binary compatibility layer. I call it the Linux personality disorder. You can natively run a substantial subset of Linux binaries on FreeBSD unmodified. You don't need their source code. You don't need to know anything about them. If you have a Linux binary, you can just execute it on FreeBSD, and it will just work because we translate the system calls. So the use cases for this are not invented here binaries for Linux like databases and CAD tools. And I know Oracle runs on it. I know EagleCAD and MentorCAD work on it. There are several other examples of things that just work. The people making the software have no idea it runs on FreeBSD, but often it runs faster on FreeBSD than it runs on Linux, which is surprising. So 11.1 release, I'm nearly done with this. I think I'm almost out of time. 11.1 release has added many improvements to ZFS. We've added lots of changes to our Wi-Fi driver. And we've ported Beehive, our hypervisor, we've ported it to ARM. So you can run a hypervisor on your Raspberry Pi if you like. But more realistically, you can run the hypervisor on your massively multi-core ARM64 system and do nice things like, I can give 8 cores to this customer, 8 cores to this customer, 8 cores to this customer. I've got 96 of them. How many customers can I put on one Beehive machine running FreeBSD? So finally, I'd like to mention our community. This is a community conference. I like the internet community. It's actually the first time I've made it to Apricot, but I hang around at other internet conferences all over the world. So the FreeBSD community has several mailing lists, just like the internet community. We have source codes, which is freely available. You can just download our Subversion code. We have a patch review system, which is largely open. So if you are not into writing code, but you like reviewing other people's code, you can come and comment on patches which people have submitted. And if you do this for long enough, then the FreeBSD community will say, we are sick of you contributing from the sidelines. Why don't you just join our community? We'll give you right access to our repository, and you get a nice FreeBSD.org email address, and this works. So our mailing lists are really friendly. We have we do not tolerate any sort of nasty behavior on our mailing lists. the FreeBSD community does not have an angry dictator who personally ensures that every new contributor is insulted, both personally and by culture or by any other community that they identify with. We are a friendly mailing list. If the worst thing that will happen to you on a FreeBSD mailing list is that you submit a 4-line patch and an angry man will comment about how you've not lined up your char pointers, but then it'll make you feel better by pointing out that it was actually broken several years ago by whoever introduced the char pointers in the first place. At no point during this discussion will you be personally insulted or made to feel bad. So learn more about FreeBSD. We have a webpage. We have source code, mailing lists, and other things. Join us and share and enjoy. And with that, I'd like to take any questions you may have.
Hi, Alain Durand from ICANN. I used to work with FreeBSD many years ago, and happy to see that the effort is still going on. I have a quick technical question for you. You mentioned jails, and you spoke a lot about them. How far do they scale today? How many can you put on a decently sized server?
Well, it depends on how big your server is. And it depends on what you're running in the jails. So jails are very lightweight. They are nowhere near as heavy as full system virtualization. So the number of jails you can run on your system is basically the number of processors you can run on your systems, because jails add very little overhead. So if you can run 1 million HTTP processes on your server, you can run 1 million customers with 1 HTTP process on your server.
So for example, I ran some systems on Linux with containers and 10,000 containers. Is this something that you could do on jails?
We could do that on jails. We could probably on the same hardware run 20,000 jails. Don't quote me on that. and don't make me buy you a beer for every jail you cannot run. But so with the Linux Docker thing is actually fairly high overhead. It's still very lightweight compared to, say, running a hypervisor or running a complete or even emulating a system. But it's still comparatively high overhead. On FreeBSD, the overhead of jails is pretty trivial.
Thank you.
But do try out your 10,000 containers and see how many you get.
By the way, this session is recorded, so whatever you said can be used against you.
I was not
Just
here.
joking.
I was not here. Yes.
Kiriti Compella with Juniper Networks.
Hello.
So we actually use FreeBSD in our OS.
Yes, you do.
And we try to contribute back. I'm not sure if our networking stack made it to, or some of the networking changes made it to FreeBSD, but we were planning that for a long time. I have a couple of questions. The slides will be available, right? Because I want to...
Yes, they are.
Yeah, okay. One question on ZFS. I used to be at NetApp before Juniper. Mm-hmm. And so I'm really interested in ZFS, but it used to be a memory hog.
Yes, ZFS really likes memory.
Okay, okay, so it's still the case. So I think we used UFS. Mm-hmm. Should we move? Should we stay?
It depends. If you have anywhere near a contemporary amount of memory, you should be on ZFS. Okay. So ZFS gets really cranky when you put it in hundreds of megabytes of memory. If you can give it gigabytes of memory, it is happy.
Okay, but we want to actually use the gigabytes for holding Jeff Houston's routing tables.
Right, so his routing tables will take, a gigabyte? so Jeff's routing tables will take a gigabyte or something, right? The internet is a very small network of, largely friendly people who all aggregate their routes very, very
nicely,
politely and civilizedly.
Yes.
So, his routing table will also keep getting smaller. Right, Jeff?
I think you missed his presentation.
So ZFS, it still really likes memory, but it is possible to tune it, and the default has also been, let's say, made a better memory citizen. It used to be that ZFS would take all your memory, and every other process on your machine would go, yeah, I'd like some memory too, please. No. So that's been changed a bit, so I think it's now capped to half of your memory, or that's the default tuning. You can change it to half of your memory up to to a maximum of, say, 16 gigabytes or 8 gigabytes, one of those numbers, a nice round number. So if you don't like that, you just say, right, here's 4 gigabytes, that's the file system, everything else is for Jeff.
Okay, yeah, sure. Yeah. Which it normally is, yeah.
So you can fight this out yourselves, right?
Okay.
But
Well, we'll play with it, but...
yes, and do let me know.
Okay. The last thing is you mentioned microservices and using, doing microservices on FreeBSD.
Yes.
And of course, you've had jails for a while, but I'm sure you've gotten better. The thing that my question is, do you have an orchestrator for the jails, whether it's living in FreeBSD or elsewhere?
There are several. So all of the ones that work on Linux, so things like Puppet, Ansible, Chef, and all those other things people use, they will just work on FreeBSD. There are binary packages for them. FreeBSD has something called EasyJail, or EZJail, as I want to pronounce it, but that's just me, which is native to jails and might work a bit better or a bit easier to configure than the ones that were primarily developed with Linux in mind. Okay. We've also got a new one now called IO Cage, which is developed specifically for jails, and it knows about jails with vimage, and I think it also knows about Beehive, but I might be talking through my hat. So there are several options. If you're already familiar with things like Puppet Chef, Ansible, or whatever, they will just work on FreeBSD.
Okay.
If you would like to get the best and the most out of FreeBSD, use something like IO Cage.
Okay, thank you.
One more question.
I'm Virapan from AIT, Thailand. I want to know if you can run Linux distributions in jail.
Yes and no. So you can run native Linux binaries on top of the FreeBSD kernel, and it is a good idea to put them in a jail. So what you cannot do is you cannot, well, not easily create a jail and it will be a Linux. It will look and smell exactly like Linux. You can't directly do that. What you can do is you can build a jail and put in all your Linux dependencies and run your Linux binary in that jail without polluting or affecting any of the other systems on there. If you want a system that looks and smells exactly like Linux, and in fact is Linux, you can run Linux on Beehive. Beehive is a hypervisor, so you'll have a bit more overhead, but you can run Linux on top of FreeBSD. So depending on what you actually want to accomplish, I would start with running whatever Linux binary you have in a jail, and if that doesn't live up to expectations, you can still use Beehive.
Yeah, just I want light weight of the GL to run Linux on it, so I can take same advantage of it.
Well, okay. Linux has very few advantages, really. But
no advantage of the jail.
Oh yes, jails have several advantages.
Yeah, not another Linux.
Yes. So yes, you can run your Linux binary in a jail, or if you have several Linux binaries you need to run, you can run them all in separate jails without them trampling all over each other.
Okay, thank you.
Let's talk about your workload a little bit later.
Thank you.
Thank you, Philip. This was great. A kind reminder that if you have more questions for Philip, feel free to reach out to him after the session. I'm sure he's not going to mind.
I'm not going
no troll walls, please. Okay. Next gentleman is Alain Durand, and he's going to speak about IPv6 adoption worldwide.
Good morning. Is that okay if I stay here, or should I move to the side? Okay. So my name is Alain Durand. I work in the office of the CTO at ICANN. And I'm going to talk to you about one of my pet peeves. It has been my pet peeve for 25 years, which is IPv6 deployment. And for 25 years, I've heard people, including me, saying, oh, it's coming in 2 years. In 2 years, it will be there everywhere. Well, we're not quite there yet. So let's look a little bit at it. These are two pictures that were taken a few months ago at one of the latest NANOG conference. It was in October, so not the last one, the one before. It's a talk I gave there. It was the last day of NANOG, the last session, and I was in between people and their beer. So pictures on the left was taken up close. Picture on the right was taken a little bit further away. So if you look at the picture on the left, you might think that the room was full. If you look at the picture on the right, you may have a different opinion. So just to illustrate in those days and age, if you only have one perspective on the data set, you may get only a partial view of it. So if you look at the statistic from Google, and that maintains some very interesting. You will have the impression that IPv6 story is one of a success story up and to the right. So we'll give it a few seconds to come back. So when you look at the traditional deployment curve of a new technology, there is usually a hockey stick type of picture, meaning there's very, very little at the beginning, and then there's an inflection point, and from there it goes to 50, 60, 80, 100% rather quickly. So one of the common thinking is, as soon as you get through that inflection point, then you're good. Then everybody jumps on the bandwagon, and you're there. When we'll get the picture. Waiting for the projector to warm up. Here we go. If you look at this picture from Google, you will say, oh, we just passed this inflection point. First, we are en route to get to IPv6 very quickly, right? Well, if I now look at this picture that I took from statistics gathered by Jeff Houston from EpiNUC, you get a very different story. It's more like a red alert. There are many countries on the planet that don't have anything, right? So let's try to go a little bit deeper at this. And clearly this first picture here shows that a global number means nothing. You really have to dig country by country, even service provider by service provider, to figure out what it is. So what we are going to measure here is what people can use. If you're at home on your computer and you're offered IPv4 and IPv6, which one can you use it? We're not measuring routing table size in IPv6, things that are turned on and off. We're really measuring what the users can see with their eyeballs. So, I'm going to skip this, all right. When we look at IPv6 penetration for users, there are two ways of looking at this. You can look at this as a ratio of IPv6 capable user per population, or you can look at this as a ratio of IPv6 user over IPv4 users. So in most developed countries, those two things are mostly the same because the penetration of IPv4 is essentially 90%, 95, 100%. Makes no difference. In some countries that are developing their network, there is a huge difference. And that's why, maybe not. This picture and this picture are not exactly the same. But let's look at this one for a second. So in this graph, I've plotted 150 countries. So the axis, horizontal axis, is 150 countries. I've taken all the countries that have at least 1 million people in there. Why? Is because the data about countries and the population for the smaller countries is, let's put it mildly, dirty. If you plot the official data over time, you realize that there are jumps that you cannot explain. And when you divide things by the number of population, it just means really something that is not very interesting. So I decided, okay, let's only focus on the largest country, 150 largest countries that have at least 1 million people. What we see here is, over the last 4 years, 2014, 2015, 2016, up to the end of 2017, you have roughly 37 countries that are showing on the radar screen with more than 5% of IPv6 availability to the users. You have another 20 countries that are somewhere between 1 and 5%, barely showing. And you have 100 countries that year after year after year are not showing on this radar screen. So I would like to pause for a minute here. Let's assume that the countries on the left that are not at 100% yet, but let's assume for a second, go to 100%. And we still remain at 0% on the countries on the right. The concern is we may not have one internet, but two internet. When people are talking about, let's deprecate IPv4. Let's not use IPv4. Let's shut down IPv4. Let's ask people move to IPv6 or forget it. Let's develop new application on IPv6. I hear that a lot. What it would mean, what it could mean, is if you're in the countries on the right, you may be out of luck. If you're in countries on the left, you'll be okay. That's not one internet, that's two internet. That is the potential concern that we are worried about. It would be much better if everybody were to go to IPv6, no doubt. But this graph doesn't show this at this very moment. So, you will notice that there are some lines that are going below 0. It means that some years we saw actually a drop in IPv6 penetration. So let's try to go now country by country and to see what is happening for those countries on the left. So I'm not going to skip this. This is the same thing zoomed out. All right, let's look at some countries. First one I'm going to talk about is Belgium. Why Belgium? Because year after year it has been the poster child of a country that deploys IPv6. Right now, according to the latest numbers that we got, 60%. You say, wow, 60%, that's great. But look at what is happening here. I don't know if it's, yeah, it is. Since 2000, yeah, about here, 2016, mid-2016 till now, there's a plateau. We are not growing more. So why? Well, there are a couple of explanations that are possible. One is, well, is a couple of ISPs who did that in Belgium, and they reached the saturation of a market. They have 100% in their customers, but all the other ISPs are not joining the bandwagon. That's one possible explanation. Another possible explanation is actually they have 100% of customers that could use it, but sometimes their customer can use IPv6 and sometimes they can't. For example, they're at home and they have a computer. Computer can use IPv6, but they go watch TV in their living room and they have a TV that's a couple years old, but they still have an IPTV stack and browse, for example, Netflix or something else. But if the stack of this TV is IPv4, even though there is IPv6 in the home, the TV will only use IPv4. So that may explain why we may be plateauing at 60% and not at 100%. I don't know which of those two explanations is the correct one. That's another interesting case. Peru. We see here we had a peak in end of 2016, and then it is going down. It's unclear why. An explanation that has been offered to me is there was one major service provider that deployed this, and that service provider is losing market share. But we'll explain why it's going down. I'm not sure if it is the correct one. More research is needed here. Oh, maybe that we have a wrong set of slides here, because I have updated with some more numbers from this local region that are not showing here. Anyway, let me continue. Switzerland. Switzerland is an interesting case. In 2015, there was big momentum. 2016, a little bit more momentum, and then a plateau around 40%. This is a pattern that we seem to see often, plateau. Estonia, same thing, essentially a plateau, different level. Austria, very, very wild swings. And on this case, I'm not quite sure why. One explanation that has been offered to me is geolocation, Because in Europe, there are some service providers that span multiple countries using maybe the same ASN. So geolocation has a hard time to actually figure out where things are, maybe. This is Germany, where we also see some kind of a maximum arriving here around 2016, and very, very slow increase, essentially a plateau, around 40%. That's the US. Overall, it's kind of a slow growth. That's actually what we would like to see, is like continuous growth. Doesn't have to be huge, but we would like to see continuous growth. Those plateaux are the things that are worrying me. China, well, this is based on Google Ads, and Google is not in China, so the fact that we don't see much there is kind of normal and expected. So I'm not going to talk more about this. Japan, pretty much like the same story as the US, is going up steadily. That's good. This is France. We see a little bit of also small growth here. This is India. So very quickly from 0 to 50%. Congratulations, India. What's going next? So I'm very curious to look at this like in 6 months from now. Are we going to see the same plateau effect, or are we going to see this going up to 100%? So hopefully it will go higher. This is Sweden. So Sweden was interesting to me because it's a country that typically adopts new networking technology early. And oops, sorry. We see only 5% here. Not quite sure why. The uploaded slides have data for other countries. So I've been looking at Vietnam, Myanmar, and a couple others in the region here. I'm maybe having some confusions, and the slides are not the one that we are projecting here. But what we're seeing in those countries are essentially the same story. There's impulsion when a service provider or a couple service providers are getting together and deploying IPv6, and very often we see those plateau effects. So, observation. When are we done? When can we say IPv4 is no longer relevant? Well, I will posit that until we reach at least some level of penetration, it's some percentage of all of the countries, we are not done. So how much is enough? It really depends. If you are a company and your business case is local to your country, you don't care about the other countries, right? Only thing that matters is your country. If you're a global company, you care about everybody. If you're a service provider that only cares about your customers, what happened to the other service provider in your country is irrelevant. So XX and YY really depends on your business model. But if you look at this from an overall internet perspective, and you try to answer at what point will IPv4 stop being relevant, I will posit that the answer is not now. We still have a long time to go. Until that point, IPv6 is not a direct replacement of IPv4. We still have to work for that goal of making sure that IPv6 is everywhere. But until there, IPv4 remains relevant, which means that there is a market today of IPv4 addresses. This market and all the other technologies, like any variation of carrier grade NAT, are going to be there for the long run. So often I hear things like NAT 6.4 are better than NAT 4.4 because they provide a way out. That is true if we go to a world with IPv6 fairly rapidly. If we stay in a long, protracted period of time, I'm talking about 10 years, 20 years, in this world where we have both IPv4 and IPv6, that's no longer true. There's no difference between that and NAT 4.4. So, further research. Why some countries that have apparently the same level of economic situation, comparable economic situation, have different stories with regard to IPv6? That's something I would like to understand better. Why, in some countries, some providers are moving ahead and some are not? That's something I would like to research also. So I'm working with some economic professors in the university to actually look at those commonalities and dissimilitudes to try to see if there are lessons that we can learn from that. And really try to understand those plateaus better. Because that's something that I was not really aware of until I started this study, that those plateaus existed. And those are not good news. We have to figure out why they came and what can be done so that we can move above that plateau to hopefully at some point the full penetration of IPv6. So that's what I wanted to share with you. I'd like to open the floor for questions, if any.
Just a second. Oh.
Jordi Palet. More than a question is trying to explain the Peru case. I know it very well, and you are basically right. It's a problem of competition. There is mainly one big provider that today provide IPv6. So if and that can be reproduced in any other country, and that may explain also variations in different countries when this provider is losing sharing. Users are moving to others that don't offer IPv6, so you drop the traffic with IPv6. So that's clear. Regarding the plateau effect that you mentioned, I am sure it's a combination of services or devices that don't do IPv6, like you mentioned the case for smart TVs, which is a very, very clear and crazy example, or PlayStation, for example, or other things like that. And also the same situation of, even if in a country like Belgium, you have most of the providers offering IPv6, maybe there is just one that is not offering that. So the churn of customers from one operator to others that change that situation as well, right?
That is correct. So the question is, let's say a country X, you have 3 major providers. One is doing it, one is kind of half doing it, and the third one is not. And the question is, why? What motivated one to do it and the other to not do it, and the third one to do it only halfly?
In my experience, that's depending sometimes of the financial aspects of the different providers. Not all of them have the same financial power. Not all of them have the same executive decision to go for IPv6 now or in 2 months, and usually that gets delayed. It's a lot of aspects and not a single one. And the other thing I want to comment, in my opinion, you are right that while we still have a lot of IPv4 traffic, that's somehow an issue, but I also believe that because it will take a lot of years, maybe 5, maybe 10, nobody knows, to have even very few number of services to be like website A, B, or C. If those websites have still, even if it's small traffic, by n millions of users in the world, that still means we have some percentage of IPv4 only traffic. And what I see is that we are going to go into a situation where more and more providers, and this is already happening especially in the cellular world, will provide IPv6 only access. And because some devices also in the LANs have only IPv4 capabilities, like all gadgets, we will have for many years maybe 20–30% of still IPv4 traffic. But probably what we need to measure there is how many providers are already delivering IPv6 in the access, not really how much traffic is IPv4 or IPv6. I know it's a different measurement, but I think it's an important measurement to do as well.
What happens when some device cannot reach the network because there's a mismatch, an impedance mismatch between what they can do and what the provider is offering. So this is a world that we have not really been thinking about for 25 years. What happens when we have those mismatches? Because some party goes too fast and some go too slow.
Well, I think it's started with IPv6 in the access, and then you provide some capability
Can you hear
to
me?
translate that.
Is this just another lightning talk disguised as a question?
So,
Thanks. Jeff?
I think that we had
Oh, yeah, sorry.
Philip before.
Philip.
I think either of us are going to give you a hard time. But perhaps I'm a loud person from Belgium. I'm not going to do a lightning talk disguised as a question, but I looked at your slides last week and I observed that the plateau in Belgium at least could be described or at least attributed to the fact that the landline operators have all turned on IPv6, but the mobile operators have not. The internet is becoming increasingly mobile, so people might be deciding that I don't actually need this computer at home, and they're now only mobile at home. And further evidence of that, so it's pseudoscience, I agree, is that you showed a graph of the US, which is steady growth, which follows the mobile trends, or India, which is 100% mobile country, which went from 0 to somewhere when one mobile operator turned on IPv6. Have you considered doing more research into the the mobile revolution, to use a terrible phrase, of the internet?
Yes.
As it reflects on the IPv6 penetration?
So short answer is yes. That's one thing we're trying to do, but sometimes it's difficult because the traffic originates from an autonomous system. And sometimes the same autonomous system is used by the same service provider to provide both wireless and wireline. In that case, it's really hard to distinguish between the two. Jeff.
So you have this is Jeff Houston, you have some questions up there, and I can give you relatively brief answers with a 1-minute lightning presentation just around this. It is a business problem, it's not a technology problem. Things that drive business come down to basically two emotive attributes, fear and greed. Almost every single business operator has a different approach to fear and greed. Fear, if I don't do it, I'll lose market share. I need to stay ahead of the game. I need to do this new thing. Greed, if I do this new thing, I'm going to make billions of dollars and you won't, so I should do this. Everyone has a different perception of that. So, why is it taking off in some but not others? The last time we did this was we killed DECnet and we killed Novell Netware. The reason why they killed is at that point the network was peer-to-peer. It was all about computers talking to computers that people owned. This is now a client-server network, and as long as the server is a dual stack, nothing changes. And so there's no incentive to do a 6-client network if the servers still support 4. I don't need to spend the money unless I've got no other choice. So the incentives for either fear or greed are not strong. Because they're not strong, you see a very laggard form of uptake. The second issue is actually the way we've implemented dual stack and happy eyeballs. We had this theory that if you strongly preferred 6, when 6 got rolled out, 4 would naturally die because you strongly preferred 6. But these days, in the millisecond hunt, I need to be a millisecond faster than you, I'll take the faster one. And if the faster one is 4, I'll keep on using 4. And so the natural signal of attrition that 6 replaces 4 becomes a very mixed signal of which is faster on the day. And that's not necessarily 4 or 6. It's a very, very rhetorical. And so we keep on seeing this because of client server. This will keep on going until we run out of NAT capacity to lend addresses and ports to clients. We don't know how far we can stretch this, but we have a kind of theory with 5-tuple NATs that we can get in excess of 10,000 customers per v4 address. Do your maths and figure that out, that realistically, if NATs are going to be here, there's an awful lot of growth in NATs, unfortunately, and the scarcity wall isn't going to hit us anytime soon. That means the fear thing dies down, greed takes over, is an opportunity in running 6, will I make more money? Hum ha, difficult answer. Thanks.
Thank you. So if I can respond quickly.
Sure.
Absolutely agree, Jeff. I think there are 2 lessons from this. The first one is an internet-wide lesson for us who are deploying new protocols or who are designing new protocols. When there is an alignment between cost and benefit, when I'm the first one, the first mover, and I get the first mover advantage to do something, things get deployed because I have this grid thing, right? And then the other people see that and they have a fear factor and catch up quickly with me. Then we have a last mover advantage where I'm actually better off holding the V6 until everybody else has been doing it because the bug will be fixed, it will be cheaper, etc., 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 and I delay my investment. When we have a protocol that has those properties, it's really, really hard to get deployed at the scale of the internet. I think this is a fundamental lesson that we are learning from IPv6. The second point I wanted to make is we are now in a pickle, as some people say in the US, because we are going to stay in this world with IPv6 and IPv4 for a long time. We need to get ready for that. We need to think about what that means in terms of policies to move IPv4 around, in terms of technologies to share addresses, because we are going to be there for the long run. This is not an intermediary stage and tomorrow in 2 years it's gone. We'll be there for the long run. We need to acknowledge this. Thank you.
So I have a last question. It's also a lightning talk disguised as a question. So I'm putting my LinkedIn hat on, and we actually measure this IPv6 versus IPv4 performance. And we also noticed that the IPv6 adoption is going down. We speak about France. We saw something in India as well. Currently, we are reviewing China because the China government decided that they also have to move forward with IPv6. So being well, one of the rare social networks that can operate in China, we have the opportunity to see the growth, the adoption of IPv6. That said, I think this was one of the discussions, I don't remember on which conference, is how the content is served. It's not only over the ISPs, CDNs also have a big role in this. And as Jeff mentioned, we speak about milliseconds. It's not that IPv4 is way better than IPv6. It's just that it's preferred because of a couple of numbers, right? And IPv4 was here for a long time, right? 30 years, and the peering agreements are still there. And I guess that everybody has to participate. It's not only about the service providers, it's also the whole community, the content providers, the CDNs as well. We all have to share the information because somebody once said that without information, it's just another opinion, right? Okay, thank you so much.
Thank you very much. Yes, it's true. What we're looking at was like different ratio or difference between V4 and V6. There are two things to consider. One is, to your point, the degree of collaboration with the provider, the CDN, and all of that. And it's true that today in IPv4, we lean on a lot of experience for many, many years, and there are a lot more CDNs and things in place. So that's one reason it goes faster. The other element is to look at the details of the protocol itself. And is there anything in the protocol that will make one faster than the other? And really, not really. It's like a lookup. And algorithms are the same. Sometimes you do a lookup on a shorter pattern or a longer pattern, but we are not talking about milliseconds here. We are talking about microseconds at best. So that doesn't explain the difference.
Yeah, so in case if you're using Sedexis, for example, right, it will prefer IPv4 just because of a small difference, right? And I think people forget to. Okay, this is going to take long. Sorry, everybody.
I'm just going to do this really quickly. You tend to say and suggest that V4 and V6 are identical in every single aspect. And that, unfortunately, is not right. The one thing where V6 completely has been a nightmare for all of us is in large fragmented packets. And the fragmentation drop rate inside people's networks is so big, we can't use it. If that packet has an extension header, its likelihood of being dropped in flight to any arbitrary user is in excess of 20%. This means you've got to rethink everything you thought about packet networking if you want V6 to be as reliable as 4. The easier approach is to avoid it. And currently, because 4 is still all over the internet, you can get away with being easy. So don't think it's apples versus apples. Underneath it all is this technical problem in 6 that we don't believe we can fix, and we've got to engineer everything else around it. This makes life even harder. There's no quick answers here. It's not a case of just talking. There's business decisions, they're all independent, and technology impetus. And quite frankly, if the world can run on 4 because that's what we're used to, we'll keep it going right up until the cliff. And then when we fall off, we'll go, shit, should have done something a bit earlier, unfortunately.
Thank you, Jeff. Okay. Thank you everybody for attending the session.